Hello? It works. Yeah, I think we can get started. Hello, everybody. My name is Simon Emanuel Schmid. I work as a solutions engineer for the company called EthAtlanta. We are the team behind the graph, the original team. In the meantime, other teams have joined, namely Streaming Fast and Figment. So it is kind of like already the development of the graph is kind of decentralizing at the moment. So today I want to explore the possibility to write subgraphs for Baseledger, so what's possible currently. But before we dive into the Baseledger subgraph, I want to quickly tell you about what is the graph by itself. So on our website, it's called APIs for a Vibrant Decentralized Future. Kind of, this is the buzzword, the marketing speech. Technically, it is an indexing protocol for querying networks like Ethereum, IPFS, and actually also a lot of others. So currently we are, like the graph supports different EVM-compatible chains like Polygon, Arbitrum, Optimism, Binance, and so on and so forth, Phantom, and more like even non-EVM compatible chains are in the making. Also, we are looking at other storage solutions than IPFS. Because this is a little bit the enterprise IT thing here, I heard. I want to quickly kind of show you in this setup, like how is an application commonly structured. So on the top, we have the presentation layer, that's usually the UI. Then we have kind of an indexing layer that prepares the data. Then we have a business logic layer, where you kind of have the business logic or how your application should work and what are the rules. And then you have a data layer where all the data is stored. And on the bottom, you have kind of a network layer where the applications talk to each other, or kind of, if you have it on your computer or on a server, usually there is some chit-chat between computers. So in a traditional application architecture, we see that the top layers, they are centralized or even locked. So let's say when you are browsing Facebook, then Facebook owns the UI, your data, the business logic, and everything else. The only thing that Facebook does not really own is like the network layer, because this is the internet and it's on top of open protocols like HTTP and IP TCP, you probably know. But the problem is like the data inside of Facebook doesn't belong to you. And if they go out of business, then maybe all the relationships that you created in Facebook are just gone also. Then the Ethereum and Web3 space came actually to challenge the status quo and came with this initialized, like decentralized application architecture. Like also this word DApp comes from decentralized application. So the idea there is like that even the presentation layer, but also the business logic layer, which in Ethereum speak are just smart contracts, and also the data layer are decentralized again. So kind of the data ownership shifts completely away from central entities to the users or to the networks. The problem that we saw in this special architecture is like to query data from the business logic layer and the data layer was very slow. For example, like when you want to see Uniswap, the trading histories of a certain pair, then usually you need to look through the blockchain like transaction per transaction and find the trades, and then you can kind of build your candlesticks or whatever chart you want. And that is actually where the graph jumps in. Like, this is the Web3 architecture that we are building currently. So you have a presentation layer that can be still centralized or not, but it can be, especially what's important, it can be changed. So for example, if you own NFTs, then it doesn't matter if you look at them on OpenSea or on Foundation or on Showtime or whatever future cool NFT app will come, because you own the private keys to your address and all the data is kind of publicly available. And we see like the graph really is at this indexing layer point. With the business logic layer, we have like Ethereum, but other chains coming like Near, Solana, and also a Baseledger somehow can be at this business logic layer. And then with data layer, we have IPFS and Arweave that we are looking at, and others that we plan to integrate. And on the bottom, again, we have still the networking layer, because even we still build on top of TCP/IP and HTTPS. So a little bit a marketing slide. So currently the graph is delivering 1 billion queries per day. This is a number from the hosted service, which is currently a centralized thing run by Edge and Node. But we are planning to, we launched the Decentralized Network in June, and since then it's possible to have like subgraphs deployed on a decentralized network in a truly decentralized way. As I said, like key applications or key dApps building on top of the graph, like Uniswap, Enzyme, Artblocks, UMA protocol, and SushiSwap, and more. So like there's, most big dApps actually on Ethereum, they build on top of the graph. So I think it's a core infrastructure. As I said, in June, we launched this decentralized indexing network protocol. I don't go very deep into it, but roughly the idea is that you have like different players. You have curators, indexers, delegators, developers, and consumers, which all kind of are incentivized through the network together to work together in a decentralized way to have this unstoppable network of data, if you want to. I'm here for the whole weekend. And if you want to dive deeper into the network economics of the graph, I'm happy to give a quick primer, or when we have time after the presentation. So the next thing that I want to look at is like a Baseledger subgraph. Because like the graph natively does not support Baseledger yet, but because the Baseledger wants to integrate or can integrate with Ethereum, it is possible to see what's going on there. But first, I quickly introduce you to the concept of a subgraph. So a subgraph by itself is basically a database schema definition. As you see, the database icon with this dots, it's not actually a database, it's just a definition, plus an instruction set, how you can watch the blockchain for events or calls or other things, and then take this out, transform it in a way so that you can put it back to that database in a way so that it is available for your dApps to query fast. So it's more or less kind of making, extracting the different protocols from the Ethereum blockchain and store what's important about them in a database for quick retrieval. And the subgraph by itself, this instruction set will then be sent to indexers, and then they start to execute that instruction set and index the subgraph. This is quite heavy, so some subgraphs, like if you do have a lot of events, a lot of going on, this can take several days. Although we are really working on making the indexing speed more faster. So this is something to improve, but just to say, I mean, like, it is for an indexer, it's kind of an investment which subgraph to index. But looking at now Baseledger, we can talk a little bit about the concept of a bridge. So like every other chain or every other system that kind of interacts with Ethereum, at some point there is a bridge. Like even like if you have a centralized exchange like Kraken or Coinbase, at some point they will send Ethereum to the Ethereum chain, and that happens with an address. And with the graph, we can watch these bridges and see what's going on. There are like not so complicated bridges like exchanges where you just see tokens and ether flowing in and out, but there are more complex bridges for the upcoming or for the layer 2s where there's actually computation that you can watch on the Ethereum main chain and then make meaning out of this and kind of track what's going on that bridge. And this is actually what we try to do here. So I prepared a little bit of live coding. I hope it works and it holds, because it's more fun if we actually see it going.
Simone, let me know when.
Sorry? Ah, yeah, sure. Hello? Do you still hear me? Okay. For those who want to follow this live coding, there's this QR code that links to a GitHub repo, which is the thing that I also use here. So it is this one. So as a first step, you probably need to have the Graph CLI installed. So you see this here. I did this already. But now the next thing we can do, we can say, okay, we are interested in this contract. So this is the staking contract for Baseledger on Robston. So we can click here and also see what's going on. Like there are transactions on this contract. We can also read the contract here. Yes. So as a next step, I can just say, I want to create a new subgraph. I initialize it. I use the host service because Robston is not supported on the decentralized network yet. Otherwise, we could use the studio. But now we use the host service. Then we can say which contract, which network. Then also here, this index events is actually going into the ABI and looking at the events and start to automatically generate code that indexes those events. And then we can also give a contract name. Let's see what happens. So, okay, so the subgraph name will be like Baseledger subgraph. Oh, I forgot one step. First, we need to go to the graph website and create the subgraph. Because we're using the legacy explorer, the way to go there is to click here on the graph explorer, and then here is kind of a very hidden link to the legacy explorer. Then we go there, and then we are on the legacy system that still supports Robston. On the top right, if you're not logged in, there's kind of a login with GitHub. I can just click here and go to my dashboard. And then I can click here and create a new subgraph. And then I say Baseledger subgraph. I can have an account. If you have Teams, you can add it here. And also what's nice is if you actually add your GitHub URL, so people who look at your subgraph later on, they can also check the source. That's it. So now I already have like created the subgraph on in the Explorer, but now I just need to actually deploy to it. So the thing here is like, this is kind of my subgraph name. It's kind of my GitHub handle slash the slugified name that I wrote before. So this is what actually they're asking me to enter here. So the subgraph name is this. Yes. Okay, and then it asks me like a directory to create in. I take this Baseledger subgraph, sounds nice. Then I do Robston, contract address I gave before. The contract name also I gave before, that's how it knows. And then it goes. It starts to clone everything and go into it and install dependencies with Yarn. We don't need to wait for Yarn, we can just go into there. And start to inspect the code. So what we have is this standard repository comes out of a boilerplate. So when you inspect the subgraph, the first thing that I look at is the subgraph YAML file. So what we here have kind of the rough definition. So we say like, okay, where's the database schema and where do I get data in? So here we have like, it's from Ethereum, it's on Robston, the name is staking, there is the address. And also here I have the entities which come from the schema. And then where the ABI is, it also has downloaded the ABI from Etherscan, and then already some event handlers. So we see like, okay, this contract emits deposit, ownership transferred, and withdrawal events. They are already created for us, which is cool. Yeah, we can also look at the schema. It's also automatically generated because we're indexing events. So this is actually not a GraphQL schema, it's a database schema that confuses a lot of first-time Subgraph developers. But we have like entities, which are tables. So we have like a deposit entity. Like for every event, we kind of have an entity. So far, it's quite straightforward. But yeah, we see like there's everything has an ID. There is beneficiaries, and there's an amount. So like a staking contract, you put some money in, and you just withdraw money. And third thing that's created is kind of the mapping file, where we have like these files. This is actually not TypeScript, it's assembly script, so it's a little bit different. But we have these files, these functions that do what they should. I mean, it's pretty straightforward. So handle deposit gets a deposit event, creates a deposit entity, fills the data, and just saves it. That's it. But what is cool is that we can run this already. One thing that is not auto-generated is start block. So you can easily get the start block from when you look at the address, the contract, then you see at which transaction the contract was created. Then you can follow the contract address and get the block number out. Because I mean, it doesn't make sense to start with block 0 when you know like that the contract was deployed at this block 10 million. So that's what we do. We go to the subgraph YML and add the start block. Start block. Okay, now we save. And then actually the next step is simply yarn. So now here I think it's installed, that's cool. So we can yarn build or yarn code again. This generates some helper functions. So we have kind of this intelligent thing in the IDE where we can start to inspect the objects. And then we can do yarn build to check if the build process works. And this works, so I can just deploy. The deploy script here comes from here, so it's everything predefined. Also, what I did before that you see in the GitHub repo is at some point you need to authenticate yourself. You see it here, this is my access token. No worries, I will kind of create a new one later, but you can find it there, and then you need to authenticate yourself so that this works. But other than that, I already deployed like my minimized Baseledger subgraph. Like it's more or less the boilerplate to the host service. Actually, I can just restart here. And then we see it's already indexing. We have to have the query here, and we can run the query. And interestingly, it already sees some deposits and some ownership transfers. Cool, right? I mean, like this was like, yeah, 10 minutes, and we already have kind of a first subgraph. But now I think this is too easy. I mean, we just indexed events. And that doesn't make it interesting. So when we look at contract, we can look at the contract here. We know it's kind of what's happening here. There are deposits, there are withdrawals. But what's actually interesting is I don't want to see just the deposits and withdrawals. I want to see like I want to query for an address and see like how many deposits has this address and how many stake is it there. So can we add to it when we see deposits and we subtract from it when there are withdrawals. So let's explore that. For this, we create a new entity called account. And that we do in the schema. And then we can also link the account to these addresses here. I have to say I cheat now a little bit because I prepared everything. So there's quite some changes here. We can walk through them. Oops. All right. Okay. So what I did is like I removed the handle ownership because it's not so interesting. I mean, like it's just like the contract is owned by someone, then it can change. We don't care. We care about the deposits with troubles. So we can also delete that function. And then also we created this account entity and started to link it. So we link it here. So I say the sender is not like just bytes anymore. Now it's actually an account, and the beneficiary is not just bytes. Also, there's actually an account. So we can save that. And then we can also see how the subgraph YAML changes. It's a little bit bigger. Here. So I removed this handle ownership changed, but otherwise more or less the same. And then the last step would be the mapping. Can also get this. Okay. So this new mapping file, actually, here I created a helper function that says, it basically says like, okay, either we need to create a new address or account in our database, and then I create it, or it's already there, then I just give it back. And then here I say, okay, and when I create the new one, I start with stake 0. That's it. And then, especially the handle deposit, we can quickly look through. So again, we create this deposit entity, and also here the beneficiary, I say like, okay, so either it's first deposit, then we need to create the account, or it's already there. But what I definitely do is like, I take the staked, so we have a staked value on the beneficiary, and we just add the amount staked with this transaction, and then we save. And also with the entity, I renamed it a little bit, so it's sender. So now you see, oh, okay, so this type doesn't exist. When you see stuff like this, usually yarn code gen resolves the problem, because I changed the schema, and because I changed the schema, these auto-generated helper files here, see these are generated, they changed, and then we had like type problems. But now with yarn type gen, code gen, I have them resolved. And actually handle withdraw is more or less straightforward. So we saw this, and then we can just say, okay, like check, does it build? Then we can just deploy again. Cool. And here we check like what's going on. Was it deployed? Not arrived yet. Now, when you deploy a new version, first it goes in the pending here. So you also have, you always have kind of the version from before that's around, it's the current version, up to the point that your newly deployed version actually syncs up. It should sync up fairly quickly, but while we're waiting, I can show you another trick. So unfortunately, this playground here, I mean, it's cool, you can do first things, but it has some limitations. So I usually use this GraphQL Online to go directly into, to have a little bit more full-fledged GraphQL Explorer. So here, for example, we can say, oh, okay, I want to see the accounts, I want to see the ID and how much it's staked. You can also do skip or ver or whatever, and you can click your queries together. So if you're not very familiar with GraphQL or just lazy, this is a very good tool to build your queries. So now we see there is just one staker, and it's staked, I don't know what this, probably 0.1 Ether. Did you just send it? Okay, cool. Do you want to send another one? So now he can send now a new transaction, or kind of can stake more, and then the subgraph will kind of index this after it saw the block, and then we should be able to query this. Here it is. So a subgraph helps you to easily kind of look at certain things on the blockchain, be it a complex DeFi application or being it the bridge to another system like the Baseledger. It is an easy way for you to kind of make meaning out of the data from the blockchain and have it ready in this convenient GraphQL interface that you can query. Yeah, I think, let me check. The slides are also here, so if I was maybe nervous, so I just created this. But in the end, you can look through them, and yeah, that's it. Thank you so much. As I said, I'm around the whole weekend, so if you want to use the graph for your project and you have ideas, I'm here. We can brainstorm, whatever. Yeah, thanks for having me.
Thanks. All right, so that's a wrap for this first session.